All right, so we have connection now. All right, so let me go back and re-explain number 12. So number 12 is because of um, line 7 and line 9. So those two combined, it will give you line 12. Line 13 is because of 5 and 11. So now we are going to line 14. So line 14 is probably about the same because Q1 exclusive or with T1 will give us D1. So that would be number 3. And we also know that D1 equals to 0. So that's how we know line 14 is, the way line 14 is expressed. So now we get to line 15, and you can see some of these have rectangles around it. The ones with rectangles around means we are resolving one of the actual bits. Instead of resolving an expression, we are resolving a particular bit. Is that okay? All right. So line 15 is now we know x1 is a 1, and it also says no need to explain, this is a given. So there's nothing you have to write here. Then we move on to line 16. So line 16, if you just look at the expression, okay, at this point of time, you probably should be able to recognize, oh, this is a really long way to say Q0 exclusive OR with T0. Okay, that's the long way of expressing exclusive OR. So now we have to ask, okay, what is Q0 exclusive OR with T0? Oh, that is D0. So that means now we have to look at things related to D0, which is also 5. And then we look at things that express T0 in the, oh, okay, so T0 is the, okay, D0, which is line 5. Okay, so 5 along with 13. So 5 and 13 together makes 16. Okay, so I'm just going to pause here because I can see some facial expressions that's, I'm not really sure how those two connect. It has to do with the way we define exclusive OR. So the definition of exclusive OR is not listed as one of the things here because it applies to any time we have exclusive OR. Yes, 5 and 11. So 5, 11, yeah, those two would work too. But if you use 13, it is more direct. It'll still be full credit. Yep. Yeah, because that one is already because of 5 and not 5 and what? 5 and 11. Yep. Sometimes. Yeah, with this one I would accept it, because it gives you the same conclusion, but the most immediate reason is just 13. In other words, I would kind of not understand why people would go for 5 and 11 instead of just 13 because if you look up, 13 is the first one you find and it is the first one that is relevant to line 16. All right, so moving on to line 17. Why do we know overflow is a 0 in this case? So if you want to know why overflow is a 0, I think number 8 is inevitable, right? Maybe not. It is 12 is 1, okay? So 12 is 1. What else? But 12 alone cannot give you the answer because 12 alone means, they can both be ones, they can both be zeros. So we need to somehow constrain, 12, the two possibilities of 12, we have to confine it to only one single conclusion, which is O is a 0. So 12 is 1, you can jot down 12 right away, but there's one more. I'm going to say 10. I'm going to say 10. Hmm? So in this case, 12 is going to be 1, okay? But 12 alone only tell us that D1 and O are both ones or zeros. They can both be ones, they can both be zeros. But if they can both be ones, they can both be zeros, and we know that 10, which is D1, is a zero, that tells us that O also has to be a zero, and coming to the conclusion of 17. Okay, so 17 is because of 12, but also because of 10. Okay, but you can also see, in this kind of question, you can get partial credit. In other words, one of these you might go like, okay, I have no idea why that is the case. You can skip it because the how you figure out the rest of the statements is not linear. You don't need to be able to answer everything before in order to answer a future one. So that means, partial credit is not only possible, it is kind of like a given. Most people can get some partial credit, because of the way it is structured. All right, so we are moving on now. We are moving on to which one? 18. Okay. So 18 is a 0. Now that one has to do with how O is defined, which is 8. And it also has to do with how in 17 we came to the conclusion O is a 0. So number 18 is because of number 17 and also because of 8. Is that okay? So now that we know number 18 or why 18 is the case, how does number 18 lead to number 19? Well, number 19 just depends on number 18 because the only time the result of an OR is a 0 is when both sides are 0. So number 18 directly implies number 19. Yep, 15 and 10. So if you have 15 and 10, yes. So uh okay. Yep, you can do it that way too. Yep. Nope. 10 alone is not enough. 10 alone means this side has to be a 0, but this side can still be a 1. Oh, 19? Oh, you mean this one? They are conjunctions, but conjunction work the same way as a multiplication when you only have zeros and ones. So if you look at 19 and which one do you want to use as an explanation? Which is D1 is a 0, definitely cannot be using it. Because when D1 is a 0, not D1 is a 1. So having only only knowing one of the three things in the conjunction is a 1 does not guarantee the whole thing is a 0. Yep. So you need to still have to mention x1, but x1 is not helpful because it is already true, but you don't know y1 yet at this point. So you cannot future reference 20. So I think the only way to answer 19 is really just 18. Just refer back to 18, and that's all you need. Because in 18 it says the result of an OR is a false, but the only way for the result of an OR to be false is both sides are false. So that would give you all you need. It's a sufficient condition. Number 18 is a sufficient condition to conclude number 19. Is that okay? It looks complicated, but the reasoning between 18 and 19 is really just the truth table of OR. Are we good so far? Yep, 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 yep. So what? How do we explain 20 then? So the way I would explain 20 is 19, 10, and also 15. Yep. So between those three, you would come to the conclusion that y1 has to be a 1 because it is the only thing inside the conjunction that is false. The other two, the other two things in the conjunction are confirmed to be true already. So the only reason for the conjunction to be false is y1 being true, which means the negation of y1 is false. So are we doing okay so far? Okay. What about 21? 21 is so the way I would look at this is to ask, what is x1 exclusive or with y1? That's actually q1. It is related to q1. Yes. Oh, sure. That has to do with the projector or the projection screen, lowering all the way. So is that helping? Okay. Yeah, just let me know when you know, when things are being blocked. Okay, so which one were we on? 21, I think. Yeah. So 21, so I would look for Q1, okay? So why do you think 21 has to do with Q1? Well, because it is defined up there, okay? Number 4, okay? But the other reason is because I studied, okay? I know Q1 is the R of x1, y1, but the R of x1, y1 for binary numbers is just the exclusive OR between those two. Okay, so the definitions that we talked about in this class directly lead to me knowing, oh, okay, probably has something to do with Q1. And sure enough, it is because of how Q1 is defined, which is number 4, and the fact that we know that Q1 is a 0. Wait, no, we cannot future reference. So we already know what is x1 and y1, right? So now we can just refer to 15 and 20. So between 4, 15, and 20, we can conclude 21. That is true. Q1 is not relevant. The next one is. Yep. Yep, you're correct. I would I got partial credit in my own test. Yes. I've told my students many times, if I were a student of my own class, I am at best a B student. So there are many factors, to become quote unquote a good student, meaning getting an A or B. I have some of those, but not all of those. Okay. I have a deep understanding of things. Okay. That's my tendency. That helps. But I have no sense of excellence, which means, I am careless. I often neglect things and forget things. So that is, and also, I make mistakes, often. So that means, I lack every single component that are necessary to become an A student, but I'm good enough to get to be a B student. So are we getting the reference to necessary versus sufficient? See, I'm slipping in, some discussion of logic, even when we talk about things that may not be focusing on logic itself. All right, so number 22. Okay, number 22 is easy because now that we figure out 21 and we know the definition from 4, so 4 and 21 both together will explain 22. All right, what about 23? So for 23, we can first look up, 2. Okay, so that's one thing that we might be able to apply. But in order to use 2, you will need to somehow figure out, the zeros. And we don't know anything about the zeros except for D0 is a 1. And D0 being a 1 means the exclusive OR is a 1. And that may not be enough. Okay, so if we use 3, then we have to, okay, I have to we're focusing on line 22. So if we want to figure out 22, then we need D1 and T1. So we know D1 here. Do we know T1? We know Q1. Yep. So that would be sufficient. Yes. So 3 and 22. 2, and 10. You need 10 too. So those will make a conclusion for 22. Yep. 14 and 22. So 14 and 22. Yep, that will work too. Yep, yep. hmm All right, 23. So 23 is saying T1 is a 0. Wait, can you mention again? 14 and 20. How did you figure out 22? Okay, let's go back to 22 first. So what was your answer for 22? 22 is because of 4 and 21. Is that what you said? Okay, so 4 and 21. Yep. Yep. So that will work. And then for 23, we can use anything. Well, okay, we can consider anything that has T1 in it. So 14 has T1 in it. 22 says what Q1 is, and that will make a conclusion about T1. Okay, so those two will explain 23. So 22 and 14 together will explain 23. All right, what about 24? 24 is actually the borrow flag of T1. So it would be related to 23 and also how T1 is defined, which is 2. So number 2 combined with 23 would explain 24. Is that okay? All right. So the way I can work on this, quickly is because I can recognize this pattern. This is the definition of T1. So I just look up at, okay, which line explains T1? So to me, it's just looking up which number corresponds to the definition because I already know which definition is useful in this case. So that part is why people who have been studying for this class has an advantage to someone who only understands the logic but not the context of the logic. People who understand the context of the logic will automatically go like, oh, okay, we need to look up the definition of blah. All right, so 24 directly leads to 25 because 24 says the result of an OR is false, but the only way for the result of an OR is false is both components of the OR being false. So 25 is a direct result of 24 with nothing else that I need to refer to. 26 is also a direct result of 24. So 24 leads to 25 directly. 24 also leads to 26 directly. And then we get to 27. So 27 has to do with something that is the exclusive OR between the Q0 and the T0, which is okay. So I'm using the mouse cursor on 27, so I can use my hand to refer to the thing that has the exclusive OR between Q0 and T0. So that would be number 16. So between number 16 and what was I talking about? 25. There we go. So between 16, 25, we can make a conclusion of 26. Wait, no, 27. Sorry, 27. There we go. Is that okay? Let me say that one more time. 16, 25 makes a conclusion for 27. Okay, why? Because we know the result of the OR is a 1. We know one side of the OR is false, so the only way for the OR to be a 1 is the other side of the OR being a 1. Okay, so once again, this can be looked up using the truth table because you already can see, oh, x is a 0, y is a 1, but we need x or y to be a 1, there's only one row corresponding to it. Okay, so we are up to 28. So 28 is Q0 has to be a 1. All right, so the question is, what else do we know at this point? Oh, okay, so 27 leads directly to 28. Okay, I know you might not be able to see the bottom because people at the back of the classroom. Okay, so 27 directly leads to 28 because 27 says the conjunction of two things is true, but the only time you have a conjunction being true is both sides of the conjunction being true. So that means Q0 and not T0, they both have to be true. So 28 is a direct conclusion of just 27. All right, so now we work with 29. So 29 is, we know the exclusive OR between x0, y0 is a 1. So now we can say, okay, we can either look up the definition of Q0, which is 28. So now we say 28 and 6. So between 6, which is the definition of Q0, and 28, which tells us what Q0 is, we can make a conclusion of 29. If we look at 26 alone, that, what? No, 26 alone cannot lead to the conclusion. I don't think. So we're looking at 28, right? Mm, no, no, it's not. It's not sufficient to make that conclusion, because in order for an and to be false, at least one side has to be false, but they can both be false too. So 26 alone cannot lead to 28. But you can see the value of this exercise. Okay, we are basically beating the truth table to a pulp right now. We are beating a dead horse until it becomes hamburger. Yes, the next time you go get a hamburger, you go like, it's a dead horse. Yes. All right. So moving on. So this is 28. We now move on to 29. Oh, we just figure out 29. So now we move on to 30. So 30 is just because of 29. That's all. Because the other way to write exclusive OR is the long version like that. So 29 leads to 30 directly. 30 leads to 31. Um, but there's one more thing. We need to make sure that this side is false, which we have concluded because of 26. So 26, 30 combined will lead to 31. And now we get to 32. So 32 says, we now know T0 has to be a 0. 27, 28. Yep, yep, that is correct. And now 33 has to do with 31. 34 is also directly because of 31. There we go. I can give you the key. I actually have a machine generated key for this entire test. So, if you have not been jotting down the answer, I can give you one version of the correct answer because some of these can have multiple correct answers. All right. So now that we know that we probably have something that looks like this, if you say, oh, I figure out every single one, even before tech, you'll figure it out. Congratulations, you're ready for this kind of question. On the other hand, if you go like, I have no idea what just happened, what would be the best thing to do between now and next Monday? But how do we study? What is studying? What does studying in this case entails? Okay. Or come to my office hour, right? But everything really boils down to a few things. One, is how the bits relate to each other using the R and the B function in this case because it's about subtraction. So knowing the definitions is important, okay? How things are derived is not as important, okay? But understanding that the R function is exclusive OR, the B function is the negation of the first parameter and the second parameter, that is important, okay? Because everything boils down to Boolean operations. Understanding the truth table for the operators is also important. So how many truth tables are we talking about? Okay, I can count everything on one hand. We have AND, OR, NOT, exclusive OR. That's it. I don't even need the fifth finger on my hand. Okay, so the truth tables are important. So do we just kind of write down the truth table, bring it on a piece of paper, and expect that we can answer all of these questions with efficiency? Probably not. Okay, just because you can answer the question doesn't mean it will be fast. So you need to internalize and really know the truth tables by heart. Okay, that would help. Okay, that's it. I mean, the first question really just has to do with definitions, how the digits are connected, and truth tables. Shall we move on to question number two? Okay, so question number two has many parts, but the reason why it has so many parts is because I want to guide you to the answer. Okay, so all the parts are basically opportunities for you to score partial credit and also going through the steps in order to figure out the last to finish the whole question. All right, so the first part of the question is okay, first of all, what is given? You are given that X is a 7-bit pattern, and it is exactly 0101 in base 2. So the first one is what is VSX7? In other words, what is the signed interpretation of X using all 7 bits? So in this case, it's going to be a 1 plus an 8 plus a 32. So 32 plus 8 is 40, 40 plus 1 is 41. So number one is 41. Are we good so far with that? So number one does not involve any thinking, does not involve any problem solving. It is just, do you know what is the definition of VS of something? Yeah, am I can be wrong because I was just doing it by heart. So we got 1, 2, 4, 8. So 1 plus 8 is a 9. 16, 32. 9 plus 32 is 41. I'm just applying the definition of VS, but doing everything in my head. You don't do that in your head, okay? When you write down the answer, you have to tell me how you got to the answer. So the simplest way to do it is simply to say it is 1 plus 8 plus 32 equals to 41. That would be acceptable to get full credit for part one. Yep, yep, exactly. Or you can have a little table with powers of 2, 1, 2, 4, 8, 16, 32, and circle the ones that are ones, and then draw arrows from all of those circles to 41, meaning that they add up to 41. That works too, okay? Because I just need to know why you know it is 41. All right, number two is the same thing, okay? Show your steps, basically the same thing. 1 plus 8 plus 32 is 41. So now number three is the two's complement of x as a base 2 number. So that would flip all of the zeros to ones and all the ones to zeros and then plus 1 to the whole thing. So that would be 1, 0, 1, 0, 1, 1, 1, because we have to remember to add 1 to the one's complement. So I'm just going to write it down because otherwise I forget, because I need that to figure out the rest. So let me go to mouse pad. All right, so just quickly write down the answer to number, this is which part again? Part 3. Okay, so part 3 is the C2 of x is 10100. Oops, nope. 1010111 in base 2. Let me just double check. 1010. Yep. Okay. So is that okay for part 3 of question number 2? Okay. So we now move on to part 4. Part 4 is once again just an application of the definition. So that means we are adding 1, 2, 4. There's no 8. There's a 16. And then we subtract the 64 from the whole thing. So that would be 23 minus 64. Arithmetics. I hate arithmetics. Negative 41. Surprising! Because if it is anything other than negative 41, then you should go back and say, did I do something wrong here? Because two's complement is how we do arithmetic negation only using binary operations. Okay, that's number 4. So we now move on to number 5. So 2.5 is consider a 7-bit number. Okay, wait. Move this out of the way so we can. Oh, wait. I got a better idea. Shrink this, move the whole thing on top. There we go. Okay, so now we're moving on to 2.5. Consider a 7-bit binary addition, x plus y. Then people will ask, but is it signed or unsigned? Then my answer to that question is, why do you care? Because it's the same mechanism, okay? The mechanism of adding or subtracting does not care about the interpretation of whether we are dealing with signed versus unsigned values. So now we are asking, what is the bit pattern y? So the VU y7 is the least value that results in K7 being a 1. Show your steps to figure out the bit pattern. Okay, so how do we proceed with this question? Okay, we always go back to definitions. Okay, we always go back to definitions. So now the question is, one clue is K7 is a 1. So now you have to remember, what is K7? K7 is the overall carry. Yep, that is correct. But how do we figure out the overall carry? So we now go like, okay, K7 is the C of x6, y6, whoops, y6, or C of q6, k6, right? So that's how you go backwards and go like, oh, okay, that has to be a 1. And then you keep going backwards. And then the question now is, oh, but at the end of the day, what does it mean when the overall carry is a 1? Why do we have an overall carry of a 1? Correct. We cannot fit something within 7 bits. But when we say we cannot fit something within 7 bits, now signed versus unsigned becomes important. Now, so are we looking at signed or versus unsigned interpretation? The carry bit is only useful when things are unsigned. Does that make sense? Okay, let's just say that we don't know whether that makes sense or not. So what do? Okay, let me re-ask the question, and I'll see what you guys are gonna think about, how you think about this. What I just said was the carry bit being a 1 means the result of an operation, quote unquote, does not fit. But there are two ways of not fitting. It's either the signed interpretation not fitting, which means with 4 bits, we are exceeding -8 to +7. That means things are not fitting. But in unsigned interpretation, it means it is outside of 0 to 15. So which one triggers the carry to be a 1? Signed or unsigned? It is unsigned. Okay. So that means, oh, okay. So that means we are looking at something that barely cannot fit within the unsigned interpretation of 7 bits. So your head is now going to, okay, what is the range of a 7-bit number interpreted unsigned? In other words, you look at VUY7, and you ask, what is the maximum that thing can possibly be? Okay, I'll write it out. Okay, so you're asking, what is the maximum of VU? Let's not call it Y, we'll call it W. Okay, okay. So what can that possibly be? Well, first thing is, what is VU of something? Okay, go to the definition of VU of something. It is really just 1 plus how many ones, how many twos, how many fours, how many eights, 16s, 32, and 64. Well, you can only have 0 or 1 of each, right? And to maximum, you can have 1 of each, which means you have 1 plus 2 plus 4 plus 8 plus 16 plus 32 plus 64, which add up to 127. But you go like, but Tech, you are just taking it through the park because there's a quicker way to get to this. Yes, we also talked about the range of an unsigned interpretation. The largest value is, in this case, 2 to the power of 7 minus 1, which is 2 to the power of 7 is 128. 128 minus 1 is 127. That would be the shorter route to it, right? What I have said is nothing new in this class. They have all been mentioned. Some of those are definitions. Some of those are things that I have given to you and go like, this is the largest number that you can represent using W bits when interpreted signed or unsigned, right? If it is a knowledge thing, you can look it up. It's in the notes. It's in the reading materials. It should be in your own notes too. It should be somewhere that you can find. Is that okay? So your preparation is knowing where to find that stuff or making sure that on the day of the exam, you know where to find that stuff quickly. Am I doing okay so far? In other words, this question at this point of time, there's nothing tricky about it yet. Okay. So the tricky part is we want to trip the carry, but just barely, which means, oh, 127 is the largest value before we trip, right? So we want the sum to be just one more than 127. So now you have to think about, okay, what is VU of x? We have determined that already, which is 41. So we want to add 41 to some value so that the result is just barely more than 127. What number is just barely more than 127? 128. Okay. So the actual question is now asking what is y when 41 plus y equals to 128? Yep, exactly. So the answer to 2.5, okay, is VU y7 is 128 minus 41. If your mental math sucks as mine and this is the exact time when I said stop writing, I will count that as at least 3 out of 4 in terms of point values. You didn't quite get me the exact answer, but you're close, okay? So now what is the question asking? What is the bit pattern? I still need it to be a bit pattern, so I'm 2 steps away from the actual answer. So we look at this and go like, okay, fine, we'll do the math. So that looks like what, 87 to you? Okay. So now We are one step closer, okay? Because one step is 87. We go like, okay, let's convert it back to base 2. How do we convert 87 to base 2? Well, one way to do it is to list all the powers of 2 that might be applicable: 64, 32, 16, 8, 4, 2, 1, okay? And then keep circling things until they all add up to 87. So let's see if I can do it mentally. So we will take care of the 46, 64 first. So we got what, 23 left. So we have a 16. Then we have 7 left. So then we have a 4, a 2, and a 1. So that would be 1, no 32, 116, no 8, 14, 12, 11. Ah, wait, that looks awfully familiar because it is also the answer to 2.3. Not by accident, it is actually by design. All right, to 2.6. So now instead of a addition, we have a subtraction, and this time we're looking at the signed value. We are now looking for the bit pattern um, so that we trip the overflow. So this time we're looking at x minus y minus z, sorry, to trip the overflow. Okay, so I already gave you a lot of clues here. Overflow, signed values. So now you have to ask yourself, what is the range of values that you can represent using 7 bits? So I gave you the range already in the notes, okay? The reading material has the actual range, okay? So in this case, it will be negative 46, 64, sorry, negative 64 to positive 63. That would be the range of signed values that can be represented using 7 bits. And I need to just go over that range by subtracting z from x. So what is x of n? What is the value of x again? So vs x7, we figured out earlier it is a 41. So we are now asking, we need 41 minus some kind of z to exceed the range. Okay. There are 2 ways for it to exceed the range. It can be either be too negative, it is less than negative 64, or it is too positive, which means it is exceeding 63 on the positive side. There is no way this can go below negative 64 because z also has to play by the same rules. The range of value of z is also just from negative 64 to positive 63. So there's no way we can hit the negative side, but we can hit the positive side because we can subtract a quantity that is negative from 41 so that we end up with this value being just barely more than 63. Is that okay? And to be exact, we want it to be exactly 64 because we need this whole thing to only barely, trigger the overflow of 1. So now we go like, this is just algebra. So solve for z. So what is z in this case? Negative 23? Yep, that is correct. So z is negative 23, and we want it to be a bit pattern in this case. So we never really quite talk about how to go from a signed value back to the bit pattern, but we already know the template, right? So we are still asking 1, 2, 4, 8, 16, 32, but we, instead of 64, we have negative 64. Each one of these is either a 1 or 0. The only way to end up with a negative value is to have one of these. So now that we know we start with negative 64, what do we need to add to it in order to end up with negative 23? So that looks like we just have to add 64 to it. And we already know what 61 looks like. 41, sorry. We already know what 41 looks like. So 41 is gonna need one of these, and also just one of these. So now this is as a bit pattern. Z as a bit pattern is going to be one of -64, one of 32, none of 16, one of 8, none of 4, none of 2, and one of 1. Does that look right to you? Let me think. We need it to be this, so we need to add 41 to it. And this is how we specify 41. I think that is right, but somehow it doesn't feel right. We need the question is asking what is the bit pattern Z? So the VS Z7 is the largest value that results in the overflow. And that's exactly what we are trying to figure out. Yeah. So we want -23 to be VS Z8, but now we are reversing to find out, okay, what bit pattern will give us the VS of Z being -23. So to get to -23, we know for sure that we need a -64, but to add something to 64 to end up with -23 means we have to add 41 to it. 41 has 132, has an 8, and has a 1. So that seems to make sense to me. All right. Well, I don't like things like it seems to make sense to me, so I'm going to double check. So to double check this, we are going to start with x, which is 0, 1, 0, 1, 0, 0, 1. That is x. And we are subtracting z from it. So in this case, z is 1, 1, 0, 1, 0, 0, 1. And then we perform the subtraction. And I'm going to do the full x, y, q, t, d subtraction. Okay, so I'm going to leave all the places available, like so. And then to go back and backfill, this is a 0. 1 minus 1 is a 0. Neither subtraction ends up with a borrow. This is going to be a 0 here. Okay, let's finish this entire row. And there's a 1. And over here we have all zeros, except we have an overall borrow of 1. And then over here we got all zeros, except for this 1. All right, so now the question is the overflow flag a 1 in this case? Just looking at this subtraction. So we look at the sign of x, the sign of y, and the sign of d, and see whether that makes sense or not. Well, it does not make sense because x is non-negative, y is negative, but the difference is also negative. The sign does not make sense, there's overflow. So I just double checked my math and made sure that my result makes sense. All right, so are we good so far? I see some of you are taking notes. Okay, very good. Some of you seems to know the answer already, which is also very good. Yep. Mm-hmm. Mm-hmm. Nope. I'm asking for the bit pattern Z. So this is the answer in base 2. Yep. Okay, let's nope, nope, because I'm looking for the z that triggers, that ends up the difference, because I'm looking at the subtraction of x minus z, which is really just the bitwise operation that I showed up here. And I'm asking what is the bit pattern z, which is the second row, okay, such that vs z7, which is the sign interpretation of whatever is on the second row, that turn I want the vs7z to be to have the largest value that result in overflow being a 1. And we know how overflow is computed or what it means semantically. So now you just need to show me the steps. So the way I got to the answer is based on what is the range of the signed interpretation. So that gave me negative 64 to positive 63. Then I have to ask, okay, in this particular subtraction, what is Vs of x? Well, that we figured out earlier, which is 41. So now we are trying to figure out 41 minus Vs z comma 7 has to get outside of that range, which is from negative 64 to positive 63. We cannot hit the negative side because z also has a range of negative 64 to positive 63, which means if z is negative, I cannot trigger the overflow. But when z is negative, I can have this difference to exceed the range by going by exceeding 63. But since I only needed to exceed 63 by 1, that's just 64. So that's how I derived the equation up here of I need 41 minus z to be exactly 64 because 64 is the first positive value that exceeds the range of a 7-bit signed interpretation. That's maybe the case, but the way I figure it out has to do with the range of values first, and then you'll do the algebra thing. Then I get to the conclusion that VSZ, okay, so this is not entirely right, okay, so in other words, if I want to be, really be clear about this is VSZ7, right? Because, Z is just a bit pattern. This is one way to interpret the bit pattern, but using the signed interpretation. So if I need VSZ7 to be negative 23, the only way to do it, okay, once and I do this, I misaligned everything else. So I have to realign everything here like this. So this is the only way to make it happen because the only way for you to end up with a negative value is to have the negative 64 component. But once you have the negative 64 component, I need the rest to add up enough that I end up with a negative 23 based on the VS definition. So that's how I can figure out the bit pattern for Z has to be 1101001. So are we doing okay so far with that chain of reasoning? Okay, it is, yes. So the question asks you about what is the bit pattern Z. So that means we need to figure out Z such that the sign interpretation of Z is the largest value that ends up with the overflow. Yep. Okay. All right. So we are good with number 2. Okay. So moving on to question number 3. Ooh, I like this one too. The drunk octopi would like this one too. Except I'm not sure anything drunk can actually answer this question. The question is about addition in base 7. So it is very clear that we are not dealing with base 10 nor base 2. We're dealing with base 7 addition. Use the following table to understand the digits that are given. So anything that is not a question mark is given to you. Assume K0 is a 0, but that's, guess what? Given to you too. Okay, so but I just want to make it extra clear that K0 is not an unknown. So the first one is only worth 5% because base conversion should be just pretty easy. So what is the decimal representation of the value represented by the y row, which is this row here? So in this case, it would be 5 times 49 plus 5 times 7 plus 3 times 1. So whatever that number ends up to be is the answer. Okay, use a calculator to help you with that calculation. Number two, figure out the related definitions. This part must be correct for the following parts to be scored because otherwise I don't understand how we can get to the answer. So in this case, what is in base 7, what is C of UW? C is the carry thing, right? So in this case, it would just be U plus W is greater than or equal to 7, question mark 1, colon 0. It's, so this part, okay, parts 2.1, 2.2, 2.3, 2.4, and 2.5 is really just regurgitation from the notes, from the reading material. Yep. As long as it is equivalent to the way that I defined those particular, relate the equations, it's okay. Yep. So as long as it's equivalent. No, as long as they're equivalent, they're okay. So part two is my gift to the whole class. It's like even if you don't understand anything in this class, only and you only can look up things, the definitions, you also earn what 25% here. Hmm? Is it 30? Well, the first question does involve, knowing how to apply the base conversion thing, but yes, it is just a definition. So nothing really hard here. So now, with number three, use the following multi-digit subtraction table to figure out and basically I just give you the empty space so I can fill them in. Okay. So let's do this. Okay. Let's go ahead and do this. And we'll use my trusty notepad here and see if we can fit everything here. Okay. Well, or we can move. Okay. Because the other one is maximized, so that's why it always wants to take over the entire screen. There we go. All right. All right. So we're going to go like something, something, something plus 553, ending up with 106 plus something, something, 0, ending up with something, something, something. Whew, nice. There we go. All right. In base 7, what do you add to 3 to get a 6? That's a 3. Okay. So now we have 3 plus 3, which is a 6. 6 plus 0 is also a 6 in base 7. Does any one of these addition, 3 plus 3 or 6 plus 0, end up with a carry of 1? Nope. Okay, so we put a 0 here. So now the question is, what plus 5 is a 0 in base 7? Yep, the answer is a 2. Okay, because 2 plus 7 is a 7, but 7 cannot be represented by a single digit in base 7. So now we have a 2 here and then a 1 over here because 2 plus 7 does have a carry of 1 in base 7. 0 plus 0 is just a 0. And now we try to figure out, oh, do we? Oh, I missed one underscore here. So there's another underscore here. All right, so what plus 5 is a 1 in base 7? Yep, it is a 3. Yep, it is a 3. So there are several ways to look at this. The number circle thing helps a lot. So just make a circle with 7 slots. You start with slot number 5, and you go like, how many ticks do I move in clockwise to end up with at the slot of 1? So that would be 3 ticks. Okay, so we put a 3 here, and we also move from zero, we cross over the 0 line when we are moving clockwise. So we have a carry of 1. So 1 plus 1 is just a 2. So that's how we figure out all the digits. Are we good with this one? All right. So the rest is really just, also just some easy points, okay? Because I want you to tell me what is the value of, oh, just one of them. The S row, the sum. So in this case, it would be 2 times 49 plus 0 times 7 plus 6 times 1. And whatever that thing turns out to be is the answer. Hmm? Oh, oh, you're fast. It's 99. Oh, no, it's 105. No, 10, 104. Yep, 104. Yep, in base 10. Yep, that is correct. All right, so that's the. Hmm? Yeah, you have to convert the whole thing in base 10, so that's 98 plus 6, which is 104. What is the decimal, which is base 10? Yeah, decimal means base 10. All right, so question number 4. Question number 4 is on doubles. So did I say double is in or not in the scope of exam 1? Did I say one way or the other? Was not. Was not? Yeah, let's say it was. So in this case, you are given that z is 1.101000001 in base 2 times 2 to the power of 5. You are also given this big mess here, which should look familiar to you, okay? Because that is exactly how we interpret the value, the double, the value of a double based on the bit pattern. Okay, so this is just me saying, well, just in case you forget to bring the class notes and your own notes with you, let me give you the definition that you need to figure out everything. So now for part 1, which is step by step, what show the value of z represented by a base 10 decimal number. So where is z? Z is right here. I want it to be a base 10 decimal number. So you just have to go like, okay. Personally, I don't want to deal with really small powers of 2 or negative powers of 2. So I'm just going to take this whole thing. Okay, so this is the way I would do it. 111. Okay, there we go. So I'm just going to move the decimal point by 5 places first. So that would be 1, 2, 3, 4, 5. I'm going to put the decimal point here, and I will start with that. Okay, because I don't like to deal with anything that is less than 1/8. Okay, so now I can go like, okay, so what is that? That is uh, 2 to the power of 5, which is a 32 plus a 16, none of 8, there's a 4, and then there's also a quarter, which is a 0.25. Add these together, we have 52.25, I think. So that's it. That's for part 1. Part 2 is to compute the biased exponent of 2 and represent it as a base 10 number and explain it. Okay, so this is for part 1. This is for question number 4, part 1. This is for question number 4, part 2. Well, this one is just looking at the 5 here and say, oh, okay, 5 is unbiased. The biased amount is 1023, so the result is 1028. 4.3. convert G to a binary number. So G is just referring to 1028. So that would be 1024 plus 4, which is 1, followed by 10 zeros. But since I have a 4, so that means I have 7 zeros and then a 100. 1, 2, 3, 4, 5, 6, 7, 1, and then by 2 zeros here. There we go. 4.4. Assemble all the bits of a double such that blah 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 blah. Okay, so the sign is going to be it's going to be a 0, and then we have the exponent for bits 62 to 60 to 52, and then we have the rest of the fractional part of the mantissa, which is 1010001, and then everything else are zeros. But wait, the question says, I can use the 0 notation, but I have to indicate how many zeros there are. So we'll just have to say, let's see, between here and here, how many zeros do we need? Well, the whole thing has to be 64 bits, right? So this is 1 bit, there are 11 over here, and then we have, so together there are 12, 13, 14, 15, 16, 17, 18, 19. So we have 64 minus 19, which is 45 bits. Okay, thank you. So there are 45 zeros within that range. So that's 4.4. And the 4.5 is just to put everything together and then reformat it as a base 16 number. Okay, so we just take this whole thing, paste it here, get rid of all the initial gaps. Okay, and then rearrange by chunks of 4. So we have chunk, 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 chunk. There we go. And then we look up the base 16 to base 2 table, which I think I have given you guys already. So look up that table. We got a 4, we got a 0, got a 4 again, got an A, got a 2, and then we have 11 zeros in hexadecimal. So I just kind of specify all 11 here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Think done. So that will be the answer. All right. So given that these are the 4 questions in the previous semester, it means you are not getting the same 4 questions. Okay, so that's one thing that is always guaranteed is if I give you a sample test from a previous semester, you are not getting exactly those questions. So what you should focus on is whether you have a thorough understanding of the concepts or not. Okay, over practicing on the previous exam is actually not productive in my classes. So the question is, are you thoroughly understanding all the concepts, starting with definitions? Okay, do you know where to find all the definitions? And then once you find the definitions, do you understand what the definitions are trying to say? So that's the knowledge part, okay, which is really important. And I would definitely start with all of that, which means you have to read all the reading material, possibly watching the recording of the lectures to kind of filter out and write down all the definitions. And then you have to ask, okay, now that I know the definitions, do I know how to make connections between the definitions so that I can solve the problems? Okay, so we got truth tables. We have, the relationship between all the digits in a multi-digit addition or subtraction. We talked about base conversion. We talked about the signed versus the unsigned interpretation of a bit pattern. And then finally, we have the double precision floating point number representation, how a real number is represented using the 3 components inside a double. So that pretty much is the scope of what we have talked about up to this point. But as you can see, the questions require you to know the definitions, you have to have the knowledge, and you also have to know how to apply the knowledge. Okay? And being able to answer all the questions in 80 minutes is also important, okay? Because back, this is especially in the pandemic days, okay? In the pandemic, I have had people, multiple people in the same class, complaining to me and go like, well, if you just give me more time, I will be able to answer all of these questions. So limiting the test time to only 80 minutes is not fair. Well, I would disagree because you have time to prepare. You have time to get kind of quicker at recalling the information. So um, the speed is important. Okay, and I don't think it is unreasonable for these four questions to to be done in 80 minutes. Okay, so that brings us to kind of one of the few last items that are also important. Okay, what is the percentage that you need to get quote unquote a pass in this class? Hmm? Nope, it is not 70. And does anyone remember from the syllabus? Nope. 62.5% is an important threshold, but that gets you into a B, not a C. If somebody says, I just want to do the bare minimum to pass this class, so I'll be on my way to make $300,000 a year, what would that be what would be the bare minimum? 37.5%, 3/8. If you score consistently 3/8 of all the points possible in every single exam, okay, and do the same thing with all the labs, which I think is really hard, you will pass this class with a C. Yes, 37.5%, which is 3/8. Yes. Hmm? You can get 100% in this test. You can get 100% in all the labs, right? So that together will add up to 40% of the 100% of all the point values. So that means if you do all the labs and get 100% with all the labs, you take this exam, it's like, okay, tech already told us everything that we need to do to prepare for this exam. I'm going to score at 100. And if you do, then you already are passing the class in general because 20 plus 20 is 40%. 40% is more than 37.5%, which is what you need to pass the entire class with a C. Then people can go like they still have to attend. They still have to take the second exam and the final exam. Otherwise, I count it as an absent. So somebody can just show up, sit down, and just say, I'm just a warm body, but I'm not doing a single thing because I know I'm passing the class already. That person can do that. Put the name on the test and walk out of the classroom and say, bye, I'm passing the class already. Do I recommend that? No. Is it possible? Yes. Am I challenging you to do that? No. But this is also why there are comments on ratemyprofessors.com. Maybe not for this class, maybe that's for 440. The comment was, it's hard to get an A in this class, but it's harder to fail the class. Because if you take notes and you've been paying attention, and I give partial credit too. It's not like you have to get everything perfectly right to get a point, okay? I give partial credit as well. So that means you kind of just have to do your best, okay? If you do your best and come to me if you have questions, and I would try my best to answer your questions. I think everybody will pass the class. Is that okay? All right. And A is 87.5% or better, hmm which is not even 90% like most classes. But I do have to give you one warning because every time I score of each part of these, I would use my scale, which is 0, 1, 2, 3, 4. It is corresponding to F to A in the GPA scale. So everything is scaled by the GPA scale, which means if I look at an answer and go like this answer has everything that I'm looking for and is 100% correct, that's 4 out of 4, which is 100%. Somebody who does not write down an answer, that's a 0. Okay, that's kind of a given. is the one in between that are kind of a little bit difficult to define. A B, which is a 3 out of 4 or 75% of the percentage of a particular part, means it is mostly correct and mostly complete. I think this person has gotten the idea correctly. It's just that there's either certain types of stupid mistakes or some kind of neglecting. Okay, so that person neglects to kind of show part of the answer. That would be a B. A C means, well, I can see the person get the most part of this, but there is a conceptual mistake somewhere. It is not critical as a conceptual mistake, but it is nonetheless an important one. A D means there's an answer. I can see the effort. I can see it relates to what I'm asking, but the most important concept that I'm testing, this person did not get it right. So that would be a D. So that's how I score every single part of a multi-part question. So I do have to make that clear because this is not one of those multiple choice exams that you get in many classes where a good percentage of those questions are really just fillers. It's like, okay, we'll just kind of fill up everything so that everybody can probably get a C or not, and then we just kind of sprinkle a few harder questions as multiple choice questions. That is not how I do assessment in this class. All right, so are we good so far? Okay. I think in this class, the labs are up to speed. The Tuesday, Thursday class is falling behind by one lab because of power fail on one particular day, but you guys are okay. So I can like not have you guys to do the lab today. So you can, you can go if you want to, but if you want to stay here and ask additional questions about this particular practice exam, I'll be more than happy to answer some of those questions. I can also give you the entire key to this exam. It is machine generated because the way I do it is, I have programs to generate questions for my exams to the point that no two students in any class would have exactly the same questions. Not only when we're talking about a small class like this, but also when the class has 60 plus students. Every student can look at the question of another student is like, every single question of mine is different from every question of yours. What is going on? Yep, I have programs to do that. But I also have programs to give me the key so that I don't have to go through a lot of mental exercise to grade everything. So I can give you the mechanically generated answer for this test, so that you guys can have a reference of what the answers are. All right, so that's it for today. Okay, once again, there's no lab, but I can stay here for as long as any one of you are here, then I'll answer your question. All right. So I'm going to stop the recorder, but you can ask questions even though it's not being recorded.